The final situation here is, let's assume that Bristol now gives a subsidy of $3,000 per day for a business that locates in its city. So we're going to redraw the payoff matrix to include the subsidy here. So this is very similar to the advertising situation, except now a subsidy is actually going to include in the profit. So rather than subtracting, we're going to add places where there's a subsidy. And we know that Bristol is going to want to encourage businesses to come in there in that particular city here. So if Joshua chooses London and Abigail chooses London, well, guess what? They're stuck with the $900 and $1,500 profit. No subsidy given here. Now, if Joshua chooses London and Abigail chooses Bristol, then you're going to add $3,000 to this amount here. $3,000. So we're going to go ahead and put in $3,500 plus $3,000. So $6,500 now. Now, if it's a reverse situation here, if Joshua goes to Bristol, then you're going to deal with a situation where instead of $3,900, he gets $7,900. Not bad for going to Bristol here. Now, what happens if they both locate in Bristol? Now you're going to get $4,800. You're going to get $4,800 for Joshua. And Abigail doesn't have quite as much total, but it's going to be $3,800. Now, kind of interesting. Is this going to change the game theory situation? I mean, a sizable subsidy might actually have an impact in where these individuals will locate here. So if Joshua chooses London, now Bristol is going to be the place of choice for Abigail. That doesn't change here. If Joshua chooses Bristol, then it's going to be a very close call here, but Abigail is still going to be better off choosing London just by $100. So Abigail here does not have a dominant strategy. So no dominant strategy for Abigail, who is the Y player, and Joshua is the X player here. Now let's take a look here at what Joshua is going to do here under this new payoff matrix here. If Abigail chooses London, then Joshua overwhelmingly will choose Bristol, $7,900. Clearly he's going to choose Bristol in this case here. Now if Abigail chooses Bristol, well, guess what? Now this changes the game here. Joshua is also going to choose Bristol. So whereas he didn't have a dominant strategy before, now he does have a dominant strategy. So if Abigail chooses Bristol, that $4,800, that extra $3,000 from the $1,800 is going to cause Joshua still to choose Bristol here. So Bristol is the dominant strategy. So here's the dominant strategy, is to go Bristol. So where's the Nash equilibrium? Well, we know that Joshua here is going to choose Bristol. So what is Abigail going to do? Abigail can basically eliminate this situation here. So let's get rid of this box. This does not exist here. Joshua will never set up shop in London. That is no longer an option. So box A and B, you can wave goodbye to them here. So let's go ahead and erase these options through the magic of technology. It is no longer there. So Abigail is now choosing between $3,900 here or $3,800. And so it's just that $100 more. If Abigail only cares about that money, then Abigail is going to choose London here. So it's still going to be the same situation here. It's still going to be the same situation. But now, what's interesting is that Joshua has a dominant strategy of going to Bristol and Abigail does not. But because of Joshua's dominant strategy, Abigail is going to go ahead and choose London. Now, there's a point of contention here. One could argue that $3,900 is simply not that much more than 100. So if for some reason Abigail is competing with Joshua and the idea of Joshua making a little bit more profit is going to really disturb Abigail, then you can make the case that Abigail is going to go for Bristol as well, because that's a $2,900 loss that it's incurring for Joshua. So if it's a relative game, then you can argue that Abigail might go for Bristol. But again, if the goal is just to make the most money possible, and that's the assumption given here, then Abigail is going to choose to go to London when this is the Nash equilibrium. Thank you for reviewing oligopoly and game theory, and I hope you return to Educator.com. Have a nice day.